Mika. Hi, sorry, I was muted. Sorry. I mute myself because when I'm setting everything up, I'm swearing a lot at the apps I'm using, and this is gonna go out of focus every 2 seconds. Okay, man, I'd go for that. Like, I'd want my students to go for that, actually. Um, Makes it, I don't know, like, because it's difficult to complete the syllabus. I think that's, I'll think about it. I'll discuss it with Sir Bilal. Okay, my video was on YouTube. Oh, I forgot to put a link on. No. Okay. As a teacher, I was out right now. I just came back. I was at the. Okay, never mind. That's too personal. Okay. Some comments are there. Our registration link is invalid. I'll try to update it. Sorry. Okay, are we ready? Let's start. New updates, schools can apply for it. Okay, all right. Chala, let's start. So today we're going to talk about, I did make notes, I'm going to use those. Okay, so wasn't following, but I did watch them later, and you guys were talking about reactivity, right? Metals reactivity series. So one of the main things you used was the reactivity series. Reactivity series. Right, and we have, we start with potassium. Oh, I don't want to write it down with this color. So you have potassium, you have sodium, then you have calcium and magnesium, just confirming, aluminum, then I want to use carbon now, and what else do we have? Zinc, iron, lead, and iron, there's also tin, iron, lead, hydrogen, and the other two, Ag and Au. Okay, our reactivity series. I have a feeling this is not in the center. Oh, looks fine. Looks fine. Okay. And you guys used the reactivity series to produce, in the last class, you saw how carbon can be used to produce iron. So iron is naturally found as iron oxide, and to turn it from iron oxide to pure metal iron, you can reduce it using carbon. And Mr. Bilal went over in great detail. I saw it, and it's just like, I knew what it was. I was watching it again, and like some of those things were like so smart. Like, yes, we were doing acids and alkalis, but I did want to go over this part as well, right? So in the reactivity series, there's 1 or 2 reactions left, and we'll do some questions. Assalamu alaikum, Marisha, how are you? And Salam Hasnu. Okay, sorry, I didn't see your salam earlier. I panicked when you said you can hear me. Okay, let's come back to this. Okay, so the idea is you saw this particular reaction take place. So iron oxide reacted with carbon to produce iron and carbon dioxide. So essentially what you're seeing is oxygen is being displaced, and let's try balancing this out. Though that's the easiest way. Let's put a 2 here, let's put a 3 here, we can put a 3 here, and we can put a 4 here, and it looks pretty balanced. Okay. And okay. So you had iron oxide, and with the help of carbon, you turned it into iron metal. So if you recall our older lecture, we were talking about different kinds of reactions and like why they're called that way and something else. So you could call this the reduction of iron oxide, but right now we'll call it a displacement reaction because in essence, it's also a displacement reaction. Carbon is displacing iron. And the reason it's able to do that is because carbon is more reactive than iron. Okay. So here's a thing. Can I take iron oxide and not use carbon and maybe use aluminum instead maybe and turn this, and will this behave the exact same way? Aluminum 2O3, and if oxygen is balanced, this is balanced, looks balanced. Okay. Will this reaction take place? Will this reaction take nitrider? Wow. Is that a reference from the 80s wala show? No, and that's Knight Rider with a K. No, some people, Buran says no, and some people say yes. It will take place. Definitely, it will take place. It will take place. Okay. I mean, I explained, right now I'm trying to explain, carbon is more reactive than iron. So it's able to displace the oxygen over here and leave iron alone and take the oxygen. How I used to see it and still entertain this thought is that iron and oxygen are dancing partners, and this cool carbon shows up. As long as carbon is cooler than, cool as in more reactive, than the other partner, it can, so to speak, steal the oxygen away from it. And carbon runs off with oxygen, and iron's like, are you serious? He takes his partner, right? That's how I see it. So as long as you're more reactive, there's nothing stopping you from taking the partner away. And that's what happens. So this reaction is completely possible. Okay, but this reaction won't be possible. Let's say you have Rn2O3. It's the worst 3 I've ever written in my life. Reacting with copper. Will this reaction take place? And you look at the reactivity series. Let me highlight the reactivity series. Okay, maybe that's a highlight. Let me also move everything a bit lower. Okay, hope that looks nice. Okay. Yeah, iron's like, why? Okay, yeah. So will this reaction take place? Copper, can it displace iron and take oxygen? Oh, I forgot to write copper down in the reactivity series. Trust me to forget something. Trust me to forget something. It's right after hydrogen. As written in the notes. Okay. This is the most important one. Copper, knowing where copper is. No, since it's less reactive, and I like how Saad's phrasing it. Saad's saying no because it's since reactive. And he's phrasing it absolutely fine. Okay, I love the phrasing. Okay, exactly. Because it's less reactive, it will not be able to displace the iron. And that's it. This reaction will not take place. Okay. Now, this is called displacement of metals, right? Metals displacing each other. This is how it's referred to as. Why is it not called a redox reaction or an oxidation reaction or a reduction reaction? Again, you're, trying to focus on a particular set. A series of reactions where a more reactive element will displace a less reactive one is you're focusing on the displacement of it rather than, of course, it's going to be redox because what isn't, okay, fine. There's a lot of reactions that aren't redox, but a lot of reactions that are also redox. But yeah, okay. So let's make a note of this. What's my note? I haven't written it down. Okay. A more reactive metal and we're strictly focusing on metals. A more reactive metal will be able to displace Someone sent a message. A more reactive metal will be able to teach. He is OJ, yeah. A more reactive metal will be able to displace a less reactive one. A less reactive one. Okay. Let's think of two more examples. Let's say we have calcium oxide reacting with magnesium oxide. Magnesium, just magnesium. Why you want to? Okay. Well, this reaction takes place. And on the other hand, okay, let's take, what do we take? Copper sulfate reacting with iron. Will this reaction take place? Let's call it this reaction 1 and reaction 2. If they don't take place, highlight that it won't take place. And if they will, what's the product? NVM. NVM. What do you guys think? What do you guys think? Yes? No? Yes? For the first one? They will? Okay. Calcium, if we go back over here, this is where calcium is, this is where magnesium is. Is calcium more reactive than magnesium? Yep. Oh, we're talking about magnesium. Is magnesium more reactive than calcium? Right? Because is magnesium, will it be able to displace calcium? No, because it's right after calcium. It's less reactive. So this reaction won't take place. This reaction will not take place. There's no reaction. Does that make sense? Okay, Saad's answering. Yeah. And then Saad's confident the second one will. Yes, it will. You'll form FeSO4 and just copper will be produced. I have a question right now. If this reaction is taking place, and one way to have this take place is, I'll give you the state symbols. It's aqueous. This is solid. This is aqueous. So this happens in water, right? So copper sulfate dissolves in water and forms an aqueous solution. Yeah, Abdul Rahim, you're on point. You got it. What would this look like? Let's say there's a beaker and this reaction is taking place. What will this look like? Any ideas? Now you need to know the color of copper sulfate, the color of iron, the color of copper, and the color of iron sulfate. Blue to green. Okay, you're saying the solution will change color. Okay, kya baat hai? This is blue in color. Okay, let's actually be. This is blue in color, and that's green in color. Right? So what's gonna happen is more and more copper sulfate will disappear and more iron sulfate will be formed, so the color change of the solution will go from blue to green. ठीक है? ठीक है? Okay. Now, boop, boop. And let's see if I can paste it. It's a little untidy. Okay, on the left hand side you see a copper sulfate solution and you put a piece of nail in it. Okay? And over time what's going to happen is the solution will not really lose its color, change its color. It'll turn green and the nail under the water area will turn copperish or pinkish. Okay. So what ends up happening, all that copper being produced gets deposited on the nail. Okay. Does that make sense? Easy? It's a very, to understand what's happening, you know, when you look at an equation but also visualize it happening is also takes some skill. So if you're getting this, that's great. Okay. Blue to green, Buran. Okay, Buran said blue to green. I thought it was Saad saying it. Okay. Okay. Should I give you more reactions, or is this understood more or less? Understood. ठीक है. Okay. ठीक है. Let me see if I can bring this here. Okay. Remember one of the earlier equations I just put in? It was iron reacting with aluminum. ठीक है. And you get fresh iron and aluminum oxide formed. ठीक है. And if I balance it, 3 is fine, this is going to be 2, and this is going to be 2. ठीक है. Now, this reaction requires a bit of ignition, but once it does, it's extremely exothermic, right? And I'll tell you how exothermic it is. This starts as a solid, and ideally you'll have them in powder form to maximize the rate of reaction. And while this is being carried out, iron that's produced is in liquid form because it's so hot, it's so exothermic. And I'll tell you where you use this. Okay, this is that reaction taking place. Okay. In this container, there's powdered aluminum and powdered iron oxide, right? And you heat it, you ignite it, it gives off a lot of heat. So what they're trying to do is repair this rail line. You can barely see it. This is a rail line going, and they're trying to join it over here. So instead of welding it and wasting a lot of electricity, they just bring these two together and ignite it. And not only it provides a lot of heat to melt iron, it also ends up producing iron. So over here, there's a small funnel that flows the iron onto the gap between the rails, and they merge together. This is known as a thermite reaction. The mixture of iron oxide and aluminum is known as thermite. Thermite. This is a thermite reaction. ठीक है. Very exothermic. Sometimes they quote this in some question. So it's good to know what exactly is going on. Okay, if this is understood, we can move on to doing some questions if everyone's okay with it. Okay, let's start. Okay. Should I just airdrop this here? Share this. Airdrop. Any questions so far? Any questions? So will it be mentioned in this particular case? Let's do some questions, Saad. I think you'll get a good idea. Like if they're asking, they won't ask for this specific sort of example how we were doing it if you're talking about the color change, but it really depends on the question. You probably don't even need to know. Why is my airdrop not working, everyone? Okay. Maybe having everyone is a bit dangerous. Import to current document. Okay. Let's look at the quality of questions. Okay, I think the first one is straightforward. What's the answer for the first one? My face is all white because of how bright the screen is. Okay. And what happened to my file? Open recent. Let's not have a A-level talk right now. Calcium? I remember doing this. You remember? Oh, okay. Mention whether the components are solid. Okay. Which metals can rapidly react with steam but reacts only very slowly with cold water? Okay. Let me do this. Copy a portion of the reactivity series. Where's my command sheet 4? So we can compare it. Okay. ठीक है. Which metal can react rapidly with steam but react only very slowly with cold water? ठीक है. Now I think we'll have a very obvious answer right after we do this. Metal rapidly with steam but very slowly with cold water. ठीक है. Now after magnesium, they stop reacting with water, and magnesium barely reacts with cold water, like almost negligible, but reacts with steam, right? But they're asking something else. So let's place where our questions are on the reactivity, our options are on the reactivity series. So we have A, we have B, we have C, and we have potassium, D. Wow. Okay. So these two won't react at all. So where C and B are out. Whereas between the two, I know potassium reacts explosively with cold or hot water. It'll react. It's the most reactive metal we have in the reactivity series. Okay. So the most obvious choice right now is calcium. And A is the answer. Okay. Saad gets it. Saad got it. Other people are kind of silent today. Attendees. Hi Miral, hi Hassan. Are you guys upset I didn't say hi to everyone? Are you sure you're on Zoom as well? And you go to YouTube? I saw you on YouTube. I was looking at your previous chat in the last class. I was like, oh, Arisha's very active. Okay, so you like, yeah, ठीक है. Both on YouTube and both on Zoom. Oh well. ठीक है. Everyone gets this? I think straightforward question. People on YouTube, do you guys get this? I know it's a little, maybe it's really obvious, but let's move on. Let's build our understanding. Let's quickly go over a few questions. 6:30, we'll be able to do a bit more. Reactive, more reactive, displace reactive. Okay. Oh, it's the same question, I'm sorry. Alloys are not, okay, let's not talk about alloys unless people want to. Let's try this question out. And I'll do this. I won't do that. I'll do. Where'd my screenshot go? Sorry. I'll move this back. Okay. A powdered mixture of metals contains aluminum, calcium, silver, and iron. Excess hydrochloric acid is added until no more mixture dissolves. What is the undissolved residue? So I have aluminum over here, then calcium, then iron, and D. Oh, that's not D. This is D. Ag is silver and Au is gold. D, obviously. ठीक है, that makes sense. Everyone understand why it's D? Because 3 out of 4 of these dissolved in hydrochloric acid, but 1 did not. Right? So if I had to bet on one of them not reacting, it would be the least reactive one. Silver is the least reactive. And the answer is D. Absolutely. ठीक है. People on YouTube, if you have questions, that's great. Please ask. Okay, we haven't done this. We'll get to this in a bit. Oh, this is almost cut out. Okay, let's not do this right now. Maybe we can. Carbon dioxide is good. Okay, I think it's a reactivity question. Can we arrange them? If you have a pen, yeah, just cheekbones are out. I lost my glasses. It's always this joke. I always see this joke. Why doesn't Sir Bilal get the joke where, like, you know, like, why is definitely less reactive? Why doesn't Sir Bilal get the joke where, like, hey, Sir Abul has changed a lot? Okay. Back to meeting.
Siri here. Let me know if I can help.
No. Sorry. I said Sir word and started. Okay, let's try doing this. Carbonate of W. Lemons, that was really funny. Carbonate of W. Carbon dioxide given off, solid changes from color of green to black. Okay, that's one observation. Carbonate of X. Carbon dioxide given off, solid does not change color. Okay, so W and X, we still don't know if what's more reactive. Carbonate Y. Carbon dioxide not given off, solid does not change color. Are heated. ठीक है, so it's less reactive. This is less reactive, so it's not decomposing. Y is over here, and W and X are here. Actually, we don't know their order, so it's W and X. ठीक है, metal Y is more reactive than metal X. No, that's not true. I don't think that's true. Metal W is a transition metal. I think that's true because it has compounds that are colored in nature. Yeah, I think we shouldn't have done this question. Transition. Do you guys know about transition elements and their colors? It's not really a reactivity series question. Changes color from green to black. So that's indicating that it is a transition element. This is correct. Y is not more reactive, Y is less reactive. Oh wait, no, that's the other way around. ठीक है, no, this is the other way around. Yeah, okay. Let's not do this. It's not about reactivity. It's not a reactive thing. Okay, let's skip this. Let's come back to this maybe later. Not this, not right now. But let's check the third one if we can get any sense out of it. If dilute nitric acid is added to all 3 carbonates, given from carbonates WX but not from, yeah, no, not this, not right now. Sorry about this, not question 6 right now. Let's go to question 7. Sorry about question 6. Sorry. W is the most reactive. Y is the least reactive. Let's try question 7 out. W is the most reactive. Siri didn't like my idea. I don't want to say that in those words. Okay, let's try this. Sorry about that question. I thought I removed it when I was compiling this worksheet. I did these questions with my students as well, like 2 days ago. I wonder when I'll see my students show up on YouTube. Like I teach at a school, I wonder. Okay, aluminum reacts with chromium oxide as shown. Aluminum plus chromium oxide gives you chromium and aluminum oxide. Okay. So aluminum is displacing chromium. What can you tell about aluminum and chromium? Chromium is not in the reactivity series. Let's bring that back. My reactivity series keeps disappearing. Can I copy it from here? That's super strange. Super strange. Super strange. That's cute. This green looks really interesting right now. Okay. Aluminum is more reactive than chromium. Chromium is Cr, I think. And the first statement is that aluminum is indeed more reactive than chromium. A similar reaction would also take place between aluminum and iron. Aluminum and iron. Aluminum is over here and iron is over here. Will aluminum be able to displace iron? Yes, it will. That's fine. Iron oxide is reduced by another metal in the blast furnace. You guys have seen 3, right? It's not by another metal. How do you reduce iron oxide in a blast furnace? How do you reduce it? People on YouTube, why don't you give me an answer? What's that special cheap element you use? Carbon monoxide. Carbon or carbon monoxide. Yes. Okay. So it's not a metal. So this is wrong. So the correct answer is B. Yes. Does that make sense? Does this answer make sense? Any questions related to this? Using carbon. Yes, Rahim. Okay. This is a question I want to do, but we'll come back to this. This is probably my favorite question in the entire 30 questions I have compiled right now. If you have a paper and pen or pencil, just do this right now. If you can do it, if you get the right answer, like, solid. Liquids and gases. Lemons, there's a person, you guys can't see it, people on Zoom. There's a person named Lemons on YouTube, and they have a vibe going. Their profile picture is like a lemon yellow, just that, and their name is Lemons. It's a whole vibe. Pretty cool. Oh, someone's messaging. Someone just said okay. Using carbon. What do you guys think is the answer? Are you guys doing it? What is the answer to this? The following facts are known about 4 metals, PQ, R, and S, and they're showing some reactions. The answer is B. I think you're right. Sir, can we get your notes? Arisha, now you're on YouTube. You were there on Zoom? Or are there? Oh, there are 2 Arishas. Oh. Arisha, you want which notes? Notes for? I'm reading just I. Yeah, I think it's B. If you can do this, this is one of my favorite questions because it's so useful. Okay, or not useful, but fun, I guess. The following facts are known about four metals, P, Q, R, and S. R displaces P and S from aqueous solutions of their ions. So it could be aqueous or anywhere. If it's displacing it, R is more reactive than P and S. Q reacts with water, but R does not react with water. So Q is more reactive than R. S does not react with acid, but P does react with an acid. So P and S are less reactive than R, but S is less reactive than P, right? S does not react with an acid, but P does react, yes. So that's the reactivity, QRPS. And B is indeed QRPS. The answer is B. Arisha, I did post it up. It's on Noon and it's on Teaching Circle. And I'll also update that link later today, so you can have it. Yeah. And in the redox video where I was talking about, I believe, reducing agents and oxidizing agents, there's a link below in that video as well. So if you want them right now. ठीक है. All right, Arisha. ठीक है. Question number 9 done. Question number 10 we'll get to. All right, let's try this. I believe we'll need the reactivity series. Thank you for pasting without any hassle this time around. Oh, I shared a link. I think it's probably sometime, so it's probably gone down in the, the feed. I'll share a new one today. ठीक है, Risha. I was moving some stuff around and and I'll just update it. There are a few more revision notes for other chapters. And once that's ready, I'll just share it today. You're all welcome. Magnesium sounds right. C, magnesium, people know their stuff. Okay. C, metal X oxidizes, the formula of the oxidizes. This is another way of just saying, them telling us the charge on the metal is 2+. X displaces zinc from aqueous zinc nitrate. X is also more reactive than zinc. Where is zinc? Over here. So X is before zinc. ठीक है. So which could it be? Aluminum is here. This is B, this is C, and we have D. Now it could be DCA. All of this could displace zinc from zinc nitrate, but the ions they form, sodium forms a positive ion, so it'll be Na2O, not NaO. Magnesium would be MgO, and aluminum would be Al2O3. So magnesium fills that requirement. So the answer is C. Kudos to people who got it. ठीक है? Any explanation further needed on this? I think this could have been a challenging question for some. ठीक है. Yeah. ठीक है, the formula is one metal with an oxide. ठीक है. I love questions when they give you the reactivity series. Aren't they fun? Four metals and hydrogen are arranged in order of decreasing reactivity. Which statement about these elements is correct? Aluminum is formed when aluminum oxide is heated with hydrogen. Okay. I don't think so. Because aluminum oxide, hydrogen won't be able to displace aluminum because it's less reactive. So A is wrong. Copper displaces zinc from zinc sulfate. Again, copper is below zinc, right? No. Copper is formed when copper oxide is heated with hydrogen. Copper is formed, oh, that could work. Yes, that could work. Copper oxide, no, wait. What? Copper, yeah, okay. That makes sense, copper oxide. Okay, TK, why not? TK, when added to water, aluminum forms positive ions more readily than potassium. What do you guys think about D? Elements below with magnesium below generally do not react with water. Like, yeah, like you can blindly trust they won't react. Okay, I believe the answer is C. The answer is C over here. Okay, potassium will form ions more readily because it's more reactive. That's why you see it being readily forming, it trying to readily form ions because it just catches fire. By the way, do you guys know, I think Sir Bilal didn't tell you guys, did you guys know, let me get this, did you guys know this particular fact that, let's say I have a piece of iron, okay. It will readily oxidize in the presence of oxygen, and you know this because it does a color change and turns what? Reddish brown. Let's say this side is exposed to oxygen and it'll start turning reddish brown. It'll start, rusting. And this is iron readily turning from pure metal iron will readily oxidize in air to form an oxide. But aluminum, which is more reactive than iron, does not do it. How could this be? Some people might know. Yes, Abdul Rahim, elements below magnesium will not react with water, and yeah. Okay, I hope I answered. I think I answered that earlier as well. But here's my question. Here's aluminum. We're talking about iron over here, pure iron, and you know iron rusts, but you also probably know aluminum doesn't rust. Or maybe that's what you've heard. For some reason, then iron, isn't it? Let me try pasting the reactivity series. Shouldn't aluminum? Yes, aluminum's oxide is amphoteric. Yeah. But let's not talk about amphoteric oxides. We'll deal with acid and bases. We're trying to talk about reactivity in general. ठीक है. Here's my question. Do you guys know, or like shrug, just like hit a question mark if you guys don't know. Spam question marks if you don't know. Yeah, okay. Isa knows her stuff. ठीक है. By the way, both are, so Isa's saying on YouTube that what aluminum does is it forms a layer of oxide over it, much like iron. Iron ka oxide is red in color. This is red in color. Aluminum ka oxide is gray in color. ठीक है. So it will rust, so to speak. It will oxidize. You don't call it rusting. But iron's oxide is बहुत chura, very powdery, right? So it breaks up. When it breaks up, and you can tell if you touch anything with rust on it, your hand's rusted, right? It comes off on your hand. So it's very powdery. When it starts falling off, it exposes the inner layer of iron, which rust even further. And that falls off, and even more and more layers of iron So each layer of iron falls off because it's rusted, and more inner layers of iron are exposed, and then over time all of that iron is rusted and all of it is just chura chura and gone. Okay, Buran is really spamming it. Okay. Aluminum, on the other hand, also does rust, and it should because it's more reactive. But the thing is, aluminum oxide is not as chura chura. By chura chura, I mean it's a Urdu word for like powdery, right? So it's not as powdery. It's more rigid, more stronger. So what it does is the aluminum oxidizes on the surface wherever it's exposed to oxygen, and all the surface is now coated with aluminum oxide. So oxygen, when it tries to get in touch with new aluminum, it cannot because there's a layer of oxide protecting the metal on the inside. And aluminum, in essence, doesn't really rust. Why is that so? It's just a different property of aluminum. Aluminum oxide is stronger than, let's say, rust. Like, that's the same as arguing why is sodium chloride very powdery and not strong, but calcium carbonate is another ionic compound, but that's really strong. You make buildings out of it, right? Calcium carbonate. Why is that the case? Because it's to do with the ionic bonds, how they are. And with iron oxide, it's very powdery and very weak. It doesn't stay as a protective layer. It's very powdery, kind of like salt, you know. It's very powdery. Still ionic, still really high melting point, but very powdery in nature. It's just to do with their structure. Aluminum oxide is more similar to calcium carbonate, or so to speak. I'm just giving an example. So it forms a protective layer around aluminum. So even though aluminum is more reactive, it doesn't rust. That's why you don't need to coat aluminum with anything. And that's also another reason why you don't see aluminum. Anytime you see aluminum, it's never shiny. It's almost always a dullish gray. That's because the oxide of aluminum is dullish gray, and the metal is bluish, ever so lightly blue, but silvery, you know, very metallic, very shiny. Okay, does that make sense? Aluminum does not rust, so to speak. High molt fire. Welcome. Okay, let's do a few more questions, then I'll do some more theory. Okay, let's do one or two, and we'll talk about something else. One more thing, then we can close the chapter on reactivity completely. What happens when a strip of silver is immersed in an aqueous solution of copper sulfate? If you were to write this equation down, it's going to be silver as a solid reacting with copper sulfate, which will be aqueous, to form what? I don't have A-level notes. Sir Bilal has a very detailed A-level notes. You can ask him. B, no reaction occurs. I think you're right. Me summoning the reactivity series again. Why does it summon there? Yeah. Okay. No, don't do that. Okay. Okay, the silver strips will start to dissolve. So silver is all the way here, that's Ag, and copper sulfate or copper is here. Silver will not be able to do anything to copper or displace it. Bubbles of a gas, no. No reaction occurs, well, essentially, how Ryan, Abdul Rahim are mentioning. Pink copper will, no it won't. The silver strip will start to dissolve, no it won't. No, it won't. B is the answer. Okay. One more. Can I find a nice question? Okay. I think we can do that question. Two statements, it's just a factual thing. Copper is below hydrogen in the reactivity series. Copper can be obtained by heating its oxide with carbon. What do you guys think? I shall summon the reactivity series. again. What do you guys think? What think? What think you? What think? My eyes. A? Absolutely. I think you guys are on the right track. Okay, copper is below. Copper is definitely below. Copper can be obtained by heating it with carbon. Carbon is more reactive and hence will be able to displace copper. So both 1 and 2 are correct. ठीक है, alright, absolutely. Chalo, that's fine. Okay, let me talk about one more thing, then we can call it, and maybe do one more question. Okay, let's say, and this is the most used example, let's say I have a piece of iron and it will rust eventually. Okay, but I can mess with this chemistry. How so? I can place it right a place or weld another metal to it. Let's say something that's more reactive than iron, or something exactly just one more slightly more reactive than iron right next to it, zinc. Okay. What ends up happening is once they're together and like this is really close, really tight, you practically welded them together, right? Because zinc is more reactive, zinc will rust first. Or oxidizes first. Okay. Rust is a word generally used for iron. Okay. So zinc, instead of iron oxidizing, zinc will oxidize. And zinc will oxidize first, and once and only when all of zinc is gone and turned into oxide and no more of zinc can turn into its oxide form, then only will iron start to rust. Okay, this is a property you see. And it's kind of confusing for people who aren't exposed to electrochemistry. It's kind of confusing, but you'll see this around. Can I repeat this again? Normally, what's going to happen is if you put zinc right next to iron and you weld them together like really tightly, okay, zinc will react with oxygen and rust first. This is something you don't normally see. It'll do it first before iron. So it won't let iron rust, even though it's not covering it or anything. It won't let iron rust until all of this is gone. Once this is all turned into oxide or actually just gone away, right? Then only will iron start to rust. This is known as, this is a very cool name for it, the sacrificial property of metals. Or is that the title? Let me get the picture for it as well. Okay. It's just called as sacrificial protection. Sacrificial protection. Protection. And it's normally used for iron because iron is very important. No, more reactive. Zinc is more reactive. Zinc, let me summon the reactivity series again. Zinc is more reactive than iron. See, zinc is over here and iron is over here. So because zinc is more reactive, it'll react first, essentially, because it's more reactive. And once all of zinc is gone, iron will start to react. Okay. Now, where do you use this? I hope this makes sense. You could use any other metal aside, anything before zinc, and they'll do the same thing. And I think aluminum is a problem because of its special properties of its oxide. It'll stop reacting, then iron's in trouble, right? Because it stops reacting very quickly. Only this outer layer of aluminum reacts. And these guys are just dangerous anyway when close to water, so they're not good. So zinc's the best choice in this list. Carbon, yeah, not carbon because it's not really a metal. Okay, but we still put it in the reactivity series of metals. Okay. Here's where they use it. It's really cool how they use it. I find it fascinating. Let me get this picture right. If you guys recognize this, this is the underside of a ship. This is a shipbuilding area. You see ships in the background, and they're trying to make this ship, and it's not put in water yet because you make it on land, then dump it in the water. So this is all made of steel. The ship is made of steel, and it's painted as well for protection and everything. But these pieces of zinc are attached to it, because once it hits water, the coating or whatever is over time will, go away, and the exposed metal will start rusting soon, very quickly, and that might ruin the ship or cause further damage. So what they do is they put pieces of zinc all around the ship, all at the bottom of the ship throughout. And what that does is zinc will prevent all of this steel from rusting, because this will first try to oxidize. Okay. And only when all of this is oxidized will iron start to rust. But before that happens, they take this zinc out, because you see these latches are there, and they replace it with other pieces of zinc. So the ship is fine. Nothing happens to the ship. Okay. Why won't aluminum be used for this? That's a good question. I'll take you back to our talk with aluminum. Aluminum can't really be used because aluminum very quickly on its own special property stops rusting. Recall this part, because aluminum, as soon as it forms an oxide layer around it, it'll stop rusting, because the oxide layer prevents anything on the inside from rusting further. So aluminum barely reacts, then stops reacting, unless you expose the layer again. So aluminum won't work. And every other metal, they'll end up going crazy. But they do use it. I've seen magnesium in 1 or 2 examples. They use magnesium. So it's not an impossibility. Okay, let's do a related question to this exercise. Let's do a related question to this. Okay. Instead of a ship, we have an iron pipe that is used to carry something underwater. Okay. I don't know what they're carrying. Maybe oil or something. The diagram shows how an underwater iron pipe can be protected from rusting. Here's an iron pipe, and metal Z can be blank because it is blank reactive than iron. Okay. How would you answer this? Miral, did my answer make sense to you? What do you guys think? Is my face hiding the answer? D? I think it's D. Okay, you got it, Miral? That's great. Okay, the answer is D, because magnesium is more reactive. That's why you use it, and you use it because it's more reactive. Okay, with copper won't do anything. And there, I believe, was another similar question to this, straight out of the example they're talking about. Let's try this. Okay. 2 pieces of iron, one with zinc attached and the other with copper attached, are placed separately in water as shown. Which statements are correct? The iron in Y will not rust. Will this rust? It won't rust because it's protected by the zinc. The sacrificial property of zinc. Iron will not rust. The water in Z will turn blue. What do you guys think? Will it turn blue? Copper doesn't really react with water, so it won't react at all, right? But between the two, iron will react with it and it'll turn green, rather, or whatever the color of iron hydroxide is, or not blue. ठीक है. And the zinc in Y will be oxidized. Zinc in Y will definitely be oxidized. Will not rust. It says the iron in Y will not rust. My bad. I read it as will rust, I believe. The iron in Y will not rust. Yeah, because zinc will rust. ठीक है. So 1 and 3. 1 and 3. The answer is C. ठीक है. Some people are saying D because I did the first one wrong, I think. So people said 2 or 3 would be correct. No, my bad. Iron in Y will not rust because this is exactly what we just saw. Exactly the same elements. Less reactive metals? No, that won't work. They're coated with less. Okay, they're coated with less reactive if they're being coated all the way around. Yes, what is going on is not the sacrificial property. Like that's, let's say you have a watch which is made of steel, right? And what you do is, because steel will rust eventually, you electroplate it with gold. But over here what you're doing is you're coating all of it, so nothing is exposed. So you're protecting that layer. So you use, that's why gold is used to electroplate pens and everything. Over here you're not doing the same thing. What's going on is the entire iron is exposed, right? If you put gold over here, this will rust. But how gold is used, let's say, is to coat the entire thing and prevent, because it's a less reactive metal. I think that's what he was saying. Does that make sense? Did he use examples of silver and gold? Metals will be coated with less reactive metals if it's all the way around, right? So it's literally like, you know, like how we take our books and plastic coat them to protect them. And that's essentially what you're doing when you use gold or silver to coat metals. But over here, you're not coating the entire thing. Even though this iron is exposed, it will not rust because the zinc will rust first. Turns out you can protect iron both ways with using a more reactive element and a less reactive element. Saad, when you said that, that's how I started thinking about that. That's interesting. Okay, so that's it, guys. That's it. My Zoom meeting just ended. Okay, I just left them. Let me see if I can join those guys again. Okay, thank you for coming. And that's it for today. If you found this useful, leave a comment. You know, thumbs up. You know the drill. Why did someone start another meeting? Okay, let's stop here. Bye-bye, guys. Take care. I hope you had fun. Was interesting. Bye-bye. Take care. A Zoom crashed? Yeah, Zoom crashed. I don't know what happened. But it's time already, so let's end it. Bye, Hasnu. Take care. Bye, guys. Take care. Bye-bye.